simplifying some rational expressions. When you're looking to simplify, you always want to ask yourself, can you factor and then cross off common factors? So if you look at this problem, in the numerator you have x squared plus 5x plus 6. Is there a combination that multiplies to AC, which is 1 times 6, or 6, that adds to B? 5. Yeah, 2 and 3. So you want to factor. Up top, we're going to write x plus 2 times x plus 3. And in the denominator, there's a GCF. You can factor out an x squared. So you'd have x plus 3 left. Then you want to see if there's any common factors in the numerator and denominator that cancel. The quantity x plus 3 cancels. So you're left with the quantity x plus 2 over x squared. You cannot cross off the x's because all 3 terms are not divisible by x. Let's look at the next one. In the numerator, you have y squared minus 81. You can use difference of squares, right? Square root of y squared is y. Square root of 81 is 9. So I'm going to write that 2 times. I'm going to put a plus or minus in between. In the denominator, I can factor out a GCF of 2. And I'm left with y minus 9. In the numerator and denominator, the quantity y minus 9 cancels. So you're left with y plus 9 all over 2. So looking at some of these next problems, we're going to do the same thing. So if you see for the next one, it says quantity 2x minus 3 over 4x minus 6. In the numerator, there's no GCF, right? 2 and 3, nothing divides out. So if there's no GCF and you can't factor, throw some parentheses around the expression. In the denominator, 4 and 6 are both divisible by 2. So in the denominator, we can take out a 2, and then we're left with 2x minus 3. In the numerator, we had 2x minus 3. 2x minus 3 factor out in top and bottom. So in the denominator, you have a 2, and in the numerator, we're going to put a 1, so 1/2. The next one, x plus 3, no GCF, can't factor, so we're going to throw parentheses around it. In the denominator, is there a combo that multiplies to AC, which is 9, that adds to B, 6? Yeah, 3 and 3. So in denominator, we can write x plus 3 times x plus 3, and we can cross off the quantity x plus 3 on top and bottom. I'll leave a 1 as placeholder on top, so we have 1 over x plus 3. That's our final answer. Let's look at the next page. Okay, so on top, these are a little tricky. On top here, it shows us, let's see if we can move this over. Okay, so it says 6v cubed plus 42v squared. So you first want to see if there's a number or letter that you can divide out. So I see that they're both divisible by v squared, and I see that they're both divisible by 6. So on top, I'm going to take out a 6, and I'm going to take out a v squared. So I'd be left with a v, 6v squared times v is 6v cubed, plus 42 divided by 6 is 7. So 6v squared times v is 6v cubed. 6v squared times 7 is 42v squared. In the denominator, you want to see if there's a GCF. So it looks like all terms are divisible by 2. So you want to go across the top and take out a 2. V squared plus 13v plus 42. Now let's see if we can factor this trinomial. Is there a combination that multiplies to 42 that adds to 13? If we're not sure, we can make a list. 1 and 42, 2 and 21, 3 and 14, 6 and 7, Okay, 6 and 7 multiply to positive 42 and they add to 13. So we would have v plus 6, v plus 7, this 2. So that's our denominator in blue and our numerator in red up here. So I'll write it off to the side. So we would have 6v squared times v plus 7 all over 2 times v plus 6 times v plus 7. Cross off quantity v plus 7. And then I see the 2 and the 6. They're both divisible by 2. So 2 divided by 2 is a 1. 6 divided by 2 is a 3. So you're left with a 3 up top, v squared, and in the denominator, v plus 6. All three terms aren't divisible by v. That's one term, that's one term, and that's one term. So you can't do anything. You just leave it as 3v squared over v plus 6. Last one. Let's take a look over here. Let's factor on top and bottom. So there's no GCF. We're going to see on top if there's a combination that multiplies to AC or negative 14 that adds to B negative 5. I'm going to make a little chart. So 1 and 14, I do positives first, and then I'll play around with the negative signs. So 2 and 7, 3, 4, 5, 6, nothing else goes in evenly. So I know if they multiply to a negative, either 1 or negative 14 to negative 7. So these are my only options. So 2 and negative 7 adds to negative 5. So 2, negative 7. So we know in our numerator we're going to have v plus 2 times v minus 7. And in our denominator, we're looking for a combo that multiplies to 4 that adds to 4. So it's 2 and 2. So we have v plus 2, v plus 2. Our v plus 2 quantities cancel the numerator and denominator, so we're left with v minus 7 over v plus 2. Can't cancel out of v. All four terms aren't divisible by v.